Okay, let me try to answer this question. This is question 10, okay? From June 2023, Eastern Cape, Mathematics Paper 2. So this is what we can do with this question. Let's read. In the diagram below, ED is a tangent to the circle passing through A, C, and E. F is the center of the circle. AC is extended to meet ED. At D and FB bisect AC. Straight lines FD, BE, and EC are drawn. So you need to make sure that you are careful with this statement, okay? And then you check your diagram so that you can be able to answer all these questions. Let's try question 10.1. Prove that EFBD is a cyclic quadrilateral, okay? So if you want to prove this, this EFB D, that it's a cyclic quadrilateral. So it means that we have a circle here. It's basically E, F, B, and D. It means we have to prove that there is a circle passing through point E, F, B, and what? And D. So whenever we prove a cyclic quad, we have to make sure that we have angles in the same sec, or maybe we can have opposite angles of a cyclic quad, or exterior angle of a cyclic quad. So let's check this one. Okay, let's start with the tangent, because they spoke about this tangent. So this is a tangent, okay? And then a line drawn from center is perpendicular to the tangent. It means that FE is perpendicular to what? To ED or DE. Let me say FE, it's perpendicular to DE. Okay? So now, and then the reason it will be radius perpendicular to the what? To the tangent. Radius perpendicular to the tangent. So if you know that these two lines are perpendicular, it means this angle here, it's 90 degrees. The angle here, it's what? It's 90 degrees. It means that we're going to say FED, it is equals to 90 degrees. So there is no reason for writing this, because we gave this reason as we are saying that FE is perpendicular to DE, because this is the radius perpendicular to the tangent. So FED, we conclude by saying FED is equal to 90 degrees. So this is our 90 degrees. So whenever these two lines are perpendicular, it means we have a 90 degrees here. So let's move to another angle. It means now, since we got this one, it means this one as well must be equals to 90 degrees. Okay? So this angle here must be equals to 90 degrees. So angle, it's angle FBD, or angle FBD is equals to 90 degrees. Why do you say this is 90 degrees? Because we have a line drawn from center, which is bisecting the chord and perpendicular to the chord, right? So you may just write line from center, and from center bisect the chord and perpendicular to the chord, perp to the what? To the chord. So it means here it will be 90 degrees as well. So these are opposite angles which are equal, okay? So we conclude by saying EFBD, it's a what? It's a cyclic quad. Why do you say this? It is because of the converse theorem. Why do you say converse theorem here? We have what? Opposite angles add up to 180 degrees. You see that? It's a converse, okay? So these two angles are opposite. Therefore, it means there is a circle passing through these points here. There is a circle passing through these points. Yes, we have a cycle passing through those 4 points. So let's move to triangle BCE. We need to prove that triangle BCE is similar to triangle FED. So BCE is this triangle, yeah? I don't know which color FT, so it's BC. So this is the triangle that we're talking about, and the other triangle it's FED. So it's this triangle, that we are talking about. So I want to make sure that you guys you'll be able to see what we are talking about. So it's these two, 1 and 2. So let's check. Okay, angle C1. This angle C1 here, it's 90 degrees. This one is 90 degrees. So 10.2, you're going to say angle C1 is equals to 90 degrees. Why do you say it's equals to 90 degrees? It is because we have this diameter AE, okay? So AE subtend 90 degrees angle. So this will be an angle in what? In semicircle. Yes, angle in semicircle. And then now we move to another angle. So another angle in this case, it will be B2, our B2 here, B2, our B2, it is equals to angle F1. This is equals to angle what? F1. F1, what do you say that B2 is equals to angle F1? It means since we have this angle here, we have this, sorry, not angle, this circle here. It means that this angle and these angles are equal. Why do you say they are equal? It is because we have what? We have the angles in the same what? Angles in the same segments. So these are angles in the same what? In the angles in the same segment. So it's because of this line and this line as well, and then there's this one and this one here. So these two angles are what? Are equal. So these are angles in the same segment. Angles in the one in the same what? Segment. And then let's see. It means now our angle C1, it can be equal to let me see. So it can be equal to FED. Angle C1, because these are the triangles that we're talking about. Okay, so this angle here, DEF or FD, FED, it is equal to angle C1, which is equal to 90 degrees. We have proven that FED is equal to 90 degrees from question 10.1. 1. Okay, so yeah, there is no reason for writing this. So angle E2, it is equals to angle E2 is equals to angle D1. So this one is the third angle of a triangle. So that's the reason. It means now triangle BCE, it is similar to triangle FED. Why do you say this? It is because we have angle, angle, angle. Okay, let's move to 10.2. 10.2, since we have proven, no, 10.3, since we have proven that these two triangles are similar, therefore we can prove that BC is equals to FA times CE divided by ED. So let's prove. So let me just write triangle BCE, which is similar to triangle FED, right? This is 10.3. So you are going to say from these two triangles, BC divided by FE, it is equals to CE divided by ED, okay, which is equals to BE divided by FD. So now we need to use two ratios at the same time, okay? We do not use three of them. So since we have three of them, we need to check, do we have BE or FD? In this statement, we do not have a BE and an FD, right? So it means we're going to use what? You're going to use these two here. So BC divided by FE, it is equals to CE divided by ED, okay? So BC, it is equals to, you cross multiply. So it's BC multiplied by ED, it is equals to CE multiplied by FE. So you need to divide by ED, you divide by ED both sides. So BC, it is equals to BC, it is equals to CE multiplied by FE divided by ED. But from the question, there is this FA. Where does this FA come from? Let's check. Our E to F, it is equals to FA. So AF, it is equals to FE. Why do you say this? It is because of radii. They're both radius. So therefore you can say BC, it is equals to, you conclude by saying BC is equals to our CE multiplied by FE, it is equals to AF or FA, right? So FA, you can just rearrange these two, divided by what? Divided by ED. So we are done. And then let's move to 10.4. With the 10.4, we need to prove that BC again is equals to AC times FE divided by AE, right? So yeah, we need to prove. Okay, so let's check this angle here. This angle here, the angle A. Let me, I don't know. Okay, let me just use this side here. Angle F or ABF. Angle ABF, it is equals to 90 degrees. Or let me say angle ABF, it is equals to angle C1. This angle here is equals to C1. Why do you say this? It is because these are corresponding angles, but the reason will be proven because in the first first question here, it's 10.2 we proved that C1 is equals to 90. So since we have this 90 and this 90, they are co-interior what angles. So this leads us to say that angle our angle ABF is 90 as well. Okay, so you can use angles on a straight line to get this one, and conclude by saying ABF is equals to angle C1, which is equals to 90 degrees. Okay, so they are both 90 degrees. There are these two angles. So let me just write 90 degrees, and the reason proven. And then now you can conclude by saying FB is parallel to what? To EC. Sorry. This FB is parallel to what? To EC. And then from here you can conclude by saying our AC, because now we're going to have a proportional theorem. So AC, it's AC, or a midpoint theorem. AC divided by BC. Yeah, it's AC divided by BC. It is equals to AE, A to E divided by FE, this one. We're going to use this triangle, this triangle. So the reason for writing this, it can be the line parallel to one side of a triangle. So it's line parallel to one side of what? Of a triangle. All right, so this is very much interesting. Oh, it's a midpoint theorem. Yeah, it's a midpoint theorem because these two sides are equal, and then we know that these two lengths here are parallel. Therefore, you can conclude by saying AF equals to FE. It's a midpoint theorem. Therefore, we use the line parallel to one side of a triangle. Okay, and then now guys, you can conclude by saying BC, it is equals to AC times FE divided by AE. Okay, yes, and then we are done. That's cross multiplication. Thank you very much, guys.